Welcome back, trio. Today we're going over solving logarithmic equations. A logarithmic equation is when you have an equation in log form where the variable is part of the logarithmic expression. In this case, we call this the argument. What's inside the parentheses is the argument, and x is part of the argument in this equation. So let's solve this equation. First thing you need to do is know that the coefficients become exponents. So we have to use that rule of logarithms, and we get log base 5 of 3x squared plus log base 5 of 2x to the 4th equals 3. Log base 5 of 9x squared plus log base 5 of 16x to the 4th equals 3. 3x times 3x is 9x squared. 2x to the 4th is 16x to the 4th. Now another rule for logarithms, when you're adding logarithm with like bases, you multiply the arguments. So we have log base 5 of 9x squared times 16x to the 4th equals 3. 9 times 16, that's going to give us log base 5 of 144 x to the 6 equals 3. Another way of rewriting this now is to solve this, we have to say this is log base 5, so 5 to what power gives us 3. So another way of doing this is saying 144 x to the 6 equals 5 cubed. So we're saying 5 to the 3rd power equals what? This is changing from a logarithmic equation to a regular equation without logarithms. Now we can solve this and say 144 x to the 6 equals 5 cubed is 125. That's 25 times 5, which is 125. Solving this, we need to divide 144 x to the 6 divided by 144 equals 125 divided by 144. X to the 6 equals 125 over 144. X equals the 6th root of that fraction, 125 over 144. So x is approximately 0.977. Again, when you have a logarithmic equation, you want to round your answers to approximately 3 decimal places or 4 decimal places, depending on your teacher. This is the approximation to 3 decimal places. I'll be back with another example. Okay, I'm back with another example solving logarithmic equations. Let's get started. First thing again, the coefficients become exponents. So we write log base 7 of x cubed to the 5th minus log base 7 of 3x squared equals 2. So the coefficients of the logarithms become the exponents of the arguments. X cubed to the 5th is power to a power you multiply, so you get log base 7 of x to the 15 minus log base 7 of 3x times 3x is 9x squared. All equals 2. Before we said if you're adding logarithms with like bases, you multiply the arguments. When you're subtracting, you have to divide your arguments. So we get log base 7 of x to the 15th, all divided by 9x squared equals 2. Here we have our logarithmic equation. We're going to rewrite it now. Log base 7 of the argument equals 2 is the same as the argument x to the 15th over 9x squared equaling 7 squared. Here we can simplify this fraction because we have x to the 15 and x squared. We can reduce that. X to the 13th over 9 equals 7 squared. And we can move the 9 over. So we can say x to the 13th over 9 equals 49. X to the 13th equals 49 times 9. And x to the 13th equals 9 times 9 is 81. Carry the 8. 9 times 4 is 36. 36 plus 8 is going to be 44. Now we're going to take the 13th root of that. X equals the 13th root of 441. And looking at a calculator, let's see, what do we get? We get 1.597. X is approximately 1.597. That's our answer. Thank you. Go Trio.